All right, we're going to go ahead and get started. Hello, everyone, and welcome. Thank you for choosing to spend your valuable time with us. Today's webinar will cover wolfSSL 2025 Roadmap, presented by Engineer Manager Chris Conlon. My name is Emma, and I will be moderating the webinar. All attendees will be in listen-only mode. If you have questions, please use the Q&A box. After the presentation, Chris will answer your questions. As always, our webinars are recorded and made available on our YouTube channel. If you'd like to stay updated with all the latest from wolfSSL, follow us on X, connect with us on LinkedIn, and subscribe to our YouTube channel. Feel free to contact us via email at facts@wolfSSL.com if you have any further questions. Before we dive into the technical presentation, I'd like to provide a brief overview of wolfSSL. Today, wolfSSL secures over 5 billion connections. We have more than 2,700 OEM customers and dozens of resellers. wolfSSL consists of over 50 dedicated employees, primarily engineers. This progress is of course supported by a strong partner network that we are very proud of. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DO178 support, a FIPS 140-3 certification and a FIPS ready offering, MQTT up to the V5 specification, SSH v2, TPM 2.0, a secure bootloader known as wolfBoot, Java wrappers and JSSC support, and commercial support for curl, and our newest product offering, wolfHSM. These offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We also offer full service consulting. Now I'd like to turn it over to Chris to discuss our wolfSSL 2025 roadmap.
Thanks, Emma. Hi, everyone. Thanks again for attending. We're going to talk today about our roadmap for this year. I know we're already a couple months into the year, but we put this together every year to essentially show you what we're thinking about doing engineering-wise this year to wolfSSL and some of our other products. We do have a couple intro slides here, and some of this will duplicate what Emma said, but bear with us here. So we secure essentially data all over the internet, all kinds of different protocols being implemented down to the cryptography level. And we have customers in all the industry verticals you can see here, plus more. And the biggest advantage in our minds, or one of them, is just a better breadth of testing. We focus on three main areas. So securing data at rest using cryptography and wolfCrypt, securing data in transit over a number of secure transport protocols, whether that being TLS, SSH, or a few others. Typically that's over TCP/IP, but can be run over really any kind of transport medium you have available. We have a good number of customers running TLS over things like serial lines, Bluetooth connections, or just memory buffers. And then we mix those together into a firmware update solution where we combine a secure transport protocol with a secure boot solution with our wolfBoot product. We have been growing as a company every year, and we continue to grow this year. So we have over 2,500 commercial customers, 17 partners that resell our products, and we think we secure somewhere around 5 billion active connections on the internet at any one time today. This slide gives you a good snapshot of our current product lineup. Our core products have always been wolfSSL and wolfCrypt. We have validated versions of those for FIPS, the most current version of that being 140-3. DO178 is the avionics certification. We also have an asynchronous crypto module that can be used on the server side with accelerator cards like Intel Quick Assist or Cavium Nitrox. Then you'll see some other protocols we have implemented. We have wolfMQTT, which is a client-side library, wolfSSH, which is a SSH client and server library. That also includes standalone client and server applications. We have a TPM 2.0 wrapper that can sit on top of pretty much any TPM 2.0 hardware module out there today. wolfBoot is our secure bootloader and firmware update solution. wolfSentry is an embedded intrusion detection and prevention system. wolfPKCS11, that's a PKCS11 interface that can sit on top of wolfCrypt and allow you to plug in underneath something that might want to consume that PKCS11 interface. wolfHSM is one of our newest products. That's a HSM, software HSM that can sit on top of a hardware HSM, thinking like automotive, like an Infineon Oryx Tricore, for example, essentially giving you an easier interface to the hardware HSM there. And then it can also expand your algorithms in software that aren't offered in hardware. Wolf Engine and Wolf Provider are used with OpenSSL. As we see more adoption of our wolfCrypt FIPS, these are easy ways to plug wolfCrypt FIPS underneath an existing OpenSSL implementation. That second row there is a set of language wrappers. So our main products are written in C. We also have wrappers for wolfSSL for Java, Python, JavaScript, and C#. And then the third row there are some applications we have available: an SSL termination proxy, a certificate enrollment protocol, a secure update solution, a command line utility. And then we do have Daniel Stenberg on board as an engineer here. So we offer support and consulting around curl with a resource constrained version of that called tinycurl. Every year we do like to put more effort into testing. So we know the more testing we can do up front, the fewer vulnerabilities make it out to you as our users and customers in our stable releases. We use Jenkins as a continuous integration server and use Google Compute Engine on the back end, along with some embedded agents. So you can see on this slide, we do everything from API unit testing through some static analysis and fuzz testing. We also like to test our customers' builds nightly. So if you or they are using a specific configure option with one of our products, we can pull that in and build that every night to make sure we don't break your specific build combination. One slide here just to kind of call out some of our major accomplishments last year. If you're following our blog, you may have seen some of these, or if you watch our change logs. But we did get our 140-3 certificate, number 4718 for wolfCrypt. That's now valid through 2029. We've been working quite a bit in post-quantum. So we've implemented MLDSA, MLCAM, LMS, and XMSS inside of wolfCrypt proper. So you can go ahead and pull those down and use those today. We've got a dual algorithm certificate support. Those are called Chimera certs, the X9.146. For DTLS 1.3, we were the first ones to implement that DTLS 1.3, and we've kind of been expanding that as the RFC has advanced. We did add server connection IP support. Our crypto callback interface lets you kind of easily call down to other crypto implementations, whether that be hardware or software, something of your choosing via callback. So we expanded that a little bit last year with SHA-3, RSA, with padding support, the post-quantum support, and then some certificate support. We expanded our C# wrapper with some features you can see there. Did some ARM assembly for ARJ32, 64, and Thumb2, for Cha-Cha-20 and Poly 1305, SHA-3, and Kyber. We did some RISC-V 64 assembly for the algorithms you can also see there. That's kind of a common trend, and you'll see we have a slide on our roadmap of how do we increase performance of wolfSSL and wolfCrypt every year. One thing distro related we did was add a crypto-wide, system-wide crypto policy support for Red Hat and Fedora for wolfSSL. And then we did integrate into some of the AutoZAR APIs for key management and cryptography. So now we can move on to our roadmap for this year. This is, things we'll be building upon what we did last year, plus some new stuff. The first category here is how do we increase, performance of wolfSSL? And so here we're going to be doing some more assembly work around RISC-V. We'll also be doing some assembly for some of the post-quantum algorithms. Specifically here on this list is the MLDSA, also standardized as FIPS 204 and previously called dilithium. We'll be doing some crypto parallelization work inside of DTLS and making that a little more generic. Wolf Arbiter is going to build on a dispatcher product that we had previously, where you can kind of dispatch crypto operations between cores or between processors on one system. So our FIPS certificate I mentioned, 4718, based on customer feedback, we are in the process of submitting for another FIPS certificate. So essentially this will expand the algorithm boundary with the algorithms and modes you can see on this slide. Most of these were brought to us by a customer with a specific need for one of these algorithms or modes. And so you'll see us coming out with that sometime this year, hopefully. Another area we like to see what we can do every year with is resource tuning. So where can we reduce stack and heap usage or footprint size? This year, one thing we're going to focus on is our static memory build. We have different ways of configuring wolfSSL as far as memory use goes. We can use all stack memory and no heap. We can use all heap and no stack. One build is called static memory, and that's our static only build. So that's useful in safety critical type environments where you can't use any dynamic memory. And that uses memory buckets. Typically, they have to be sized on a manual basis depending on your build configuration. So this year, we'd like to put together an optimization tool that can allow you to kind of more automated, optimize, and configure the memory bucket sizes. As an output of that tool coming about, we're going to ship some pre-tuned static memory pool configurations for common builds like our FIPS certificate, for example. And that's something you could just pull in without having to reconfigure the pool. For DA-178C, this is our avionics certification. We've done wolfCrypt in the past and wolfBoot. This year we'll be looking at wolfTPM, DTLS 1.2 and 1.3, and some of the certificate handling, authentication inside of TLS itself. For DTLS 1.3, there have been some RFC advancements since we implemented the protocol. So we're going to come back and try to pick some of those up. When we originally wrote our implementation, there wasn't a lot of other implementations out there to interop test against. Now there are some other implementations, and we can start doing more interop testing, and we'll do some more post-quantum interop testing with that. We'll do some testing of our post-quantum hybrid certificates in DTLS 1.3, and then also bring this into our Java wrapper and JSSE provider. Every year we like to do some ports to new projects. So these are, think of like open source type projects. On the list this year is the free radius client, Nginx 1.22, plugging our wolf PKCS11 interface underneath Firefox. So that would give you essentially a FIPS compliant browser solution. And then also in the context of FIPS, we're plugging wolfCrypt FIPS underneath WireGuard, both the C and the Go version. For hardware acceleration, these are platforms that have cryptography on board, either on the processor or via coprocessor. Every year we like to add some more of these. We have quite a number that are already supported. This year we'll be doing the STM32, MP2, U0, H7S, and N6. The NRF53 CryptoCell 312. We already did the 310 a few years ago. NXP has a IMX 93 and 94, which has post-quantum cryptography in the hardware. So that's going to be kind of a fun one to look at. We'll also be doing some vectorized AES work, which will essentially speed up AES operations on Intel and AMD type platforms. For wolfSSH, we'll be doing some post-quantum work. We'll be doing a rename of the old Kyber to MLChem, the new name for that, adding in MLDSA support and hybridized support with X25519, adding in PEM certificate support, multi-threading inside of a single SSH channel, CMake build support. That's becoming more popular. And essentially, we'll essentially maintain that side by side with the AutoConf build, AutoConf being still our primary build, but then CMake being there as kind of a secondary build system that you can use. We'll be doing some memory optimization and reduction, and then adding in Poly 1305 and Cha-Cha 20 support. For wolfBoot, first we put one slide in here for what some accomplishments were of wolfBoot last year. We've had a good amount of activity around wolfBoot and adoption onto new target platforms. So wolfBoot is our secure bootloader that operates on a dual partition manner. And so we added some more signature algorithms last year, MLDSA, ECC 521, and the PQ hybrid combination. You can see the new targets we supported there in the middle, which is a good collection. And every year we add about that many. Some new features, we added custom header support for different key stores, OTP key stores, some assembly with RMASM, universal key tools, improved our Xilinx ultrascale support. We brought this into wolfHSM, so you can use wolfBoot with wolfHSM now, and then also did the DA-178 certification. for avionics use. For this year, we'll be looking at the ability to boot up a trust zone Cortex-A hypervisor, adding new target support for the NXP IMX8 and MCX W71, a few new STM32 parts for the MP1, MP2, H7S, N6, and U0. Our goal there is essentially having 100% coverage on all STM32 parts, and we'll be working towards that. wolfTPM, this is our TPM 2.0 library. We'll be adding support for the TPM2 Certify X509 capability that allows you to certify the output of the TPM is in X509 format, adding in hardware interrupt support, and then doing some more operating system ports. We don't really have the OS list identified, but we're just kind of waiting to see what customers bring up as far as demand. wolfMQTT, this is our MQTT client. We don't have the broker side yet. That's another thing that's on our list here for this year and has been there for a few years. That would let us live on both sides of the connection and more easily do some optimization and adding in new features. This year, we'll be adding automated quality of service support for level 0 through 2, plugging some post-quantum support with wolfCrypt underneath the Mosquito broker. That's one of the more popular open source brokers that we see being used. Adding in WebSocket support, and then doing a lightweight sensor network SN gateway. For wolfCLU, this is our command line utility. The idea here is that wolfCLU could replace OpenSSL usage from the terminal or the command line for things like search and keygen, signing, verifying, hash generation, etc. So here we'll be doing some post-quantum testing now that we have some post-quantum algorithms added to wolfCLU. We'd like to move it into the wolfSSL package proper. So then when you do a make install in wolfSSL, it gets installed into your bin directory. Internally, we'll be doing a little simplification project where we're trying to reduce our dependency on our own OpenSSL compatibility layer. wolfSSL has an OpenSSL compatibility layer, which is used to typically port into projects that had used OpenSSL. Some of that has kind of extended functionality, which is why we used it in wolfCLU. But now we're trying to switch some of that back over to just the native wolfSSL APIs. For language wrapper support, we'll be working on our C# wrapper a little bit, adding better HMAC support and certificate parsing. For Rust, in the past, and currently we do have a wolfCrypt Rust provider for Rust TLS, Russells. And so that can be used with normal wolfCrypt or with wolfCrypt FIPS. This year, we'd like to write our own wolfSSL safe wrapper. So you can just use wolfSSL's TLS layer right from Rust. There's some third-party ones out there, but we'd like to have one internally that we can more easily maintain. And then PyTorch, that's a machine learning library. We're going to look at what makes sense as far as integration into that goes. For wolfHSM, like I mentioned, this is one of our newer products, so we do have a lot of activity going on around this right now. We'll be adding support for wolfBoot on the server side, essentially being able to boot up the HSM, adding support for keeping state of LMS and XMSS post-quantum signers. We'll be adding a PKCS11 interface on top of the HSM server, and then adding some client prioritization support into the reference server. For post-quantum, I mentioned we've been working with post-quantum for quite a while, more than a decade now. We started with the original NTRU from Security Innovation, and then we've been following the NIST post-quantum advancements since then. Like I mentioned, we do have the FIPS 203 and 204 implemented inside of wolfCrypt now, which is MLChem and MLDSA. The third FIPS standard so far is the FIPS 205, which is SLHDSA based on Sphinx Plus. We'll likely implement that one this year. And when we do these implementations, we also try to optimize them as much as we can for embedded friendliness. There's some other countries that are looking to standardize on different algorithms that are different than the US. So Photochem and McLeese come from that category. We'll keep an eye on those countries, and if they do standardize on something else, we'll likely come back and implement the algorithm that they choose there. PQ Connect is an open source project we learned about last year. It's a way to layer post-quantum crypto support on top of a Linux Unix system that doesn't have it yet. It doesn't yet support an embedded target, so we thought it'd be fun to kind of port that down, doing it at the embedded level. The FIPS 203, 204, 205, they're to the point where we can do ACDP algorithm certificates from NIST. So we're going to go ahead and start that process ideally this year. That'll have two benefits. The first, it'll help us verify our implementations are working correctly. And then the second one is that we can use that as an input to a future FIPS certificate to bring some of the post-quantum algorithms into a FIPS cert. And the last one there is adding chain signatures for LMS and XMSS. This slide is here just as a reminder that we do offer support packages and consulting for curl. We can add features that you would like to accelerate past the mailing list, for example. We also have Tiny Curl, the resource constrained version of curl, and we commonly port that to new RTOSs, new platforms. So that's something we can easily do as well. Some other plans that didn't fit in those categories. Internally, we're working on a lightweight IP, TCP IP stack called wolfIP. That would be a stack that doesn't use any dynamic memory. So it'd be usable from safety critical environments that would have easy, tight integration with wolfSSL products. So that's something that you'll see rolling out hopefully sometime this year. We're going to be doing an update on our ECH encrypted clientele support, doing some algorithm expansion of our wolfcrypt kernel module. That's commonly used for, again, wolfcrypt FIPS in kernel space. We'll be looking at adding ASCON support. That was one of the NIST lightweight cryptography algorithms. And then we'll be taking a pass over the FIDO2 specification. We just want to make sure wolfcrypt has everything that the FIDO2 users need there. We think it does. We just need to take one more pass through there. So that kind of brings us to the end of what we've got outlined so far for the roadmap for this year. This is a little bit dynamic and it can change based on what we're hearing from users and customers. As far as what the most frequently heard items are, typically make it to the roadmap level. And with that being said, I guess I'll open it up. If you guys have any questions or any items you'd like us to look at, feel free to let us know and we'll take it into consideration.
Oh, that's awesome. Thank you, Chris. Just to kick off the questions, I'd like to evaluate some of your post-quantum cryptography support. What are the best resources to look at to get started?
Yeah, so there's a few areas you can look for post-quantum crypto support. Probably the first one is looking in the wolfSSL manual. Appendix G has experimenting with post-quantum cryptography section. And so that'll go over what algorithms we support, also give you some interesting information like footprint sizes and benchmark numbers as far as how they compare to traditional cryptography. We also have some YouTube recordings you can reference. We have one called Post Quantum Cryptography Update. And then we've done a number per product, like we have one specific to curl or one specific to wolfHSM or to the CNSA 2.0.
Wonderful. How long does it take wolfSSL to add support for a new embedded hardware cryptography engine?
Yeah, that'll vary a little bit. So depending on the complexity of the hardware that we're looking at, it's typically 1 to 2 weeks. And we can either add those directly into wolfSSL. So you'll have a new define that you can define when compiling our product, and we'll just switch on hardware crypto support. Or we can do that through our crypto callback interface. If the crypto API, you don't want that to go back into wolfSSL proper.
Awesome. I think it's the final question here. Does wolfSSL support running on Zephyr?
We do, yeah. So we've supported Zephyr for a while now. If you look in wolfSSL, there's a Zephyr subdirectory right in the root, and that's where you'll find the core of our Zephyr support. It also ships us some sample or example applications for like a wolfcrypt benchmark test application, and then a couple TLS level examples as well.
Wonderful. Also, I lied. There's a few more questions. Are mitigations for side channel analysis, example SPA, DPA, CPA, being included in the crypto algorithm implementations?
We do have some side channel analysis preventions. We have some timing side channel attack countermeasures that we've done. It's a little bit dependent on which math library you're using underneath wolfSSL or wolfCrypt. We had TFM, which is the fast math library, and that had the timing resistance built or added on afterwards. Our new SP math library is just built from the ground up with timing, kind of constant time in mind. As far as the other ones, we have a little bit in the context of, if some researchers have contributed certain things to us. Um, we'd have to double check on the specific defines, but inside of wolfSSL, there are a couple areas that are specific to some of those.
Wonderful. Are these improvements all made to the open source version together with the commercial version?
Ideally, yes. Our preference is that everything we do gets contributed back into the open source version of wolfSSL and products. There are some cases where customers don't want certain changes to go back into open source, but that's the rare case. Most of them do end up going back into open source.
Wonderful. Well, thank you so much, Chris, for hosting an informative webinar. Thank you to everyone for joining. I will email a copy of the webinar recording and PDF slides. You can keep up with our upcoming events, meet our team in person, read our blog posts, and get the latest wolfSSL updates by following us on X, connecting with us on LinkedIn, and subscribing to our YouTube channel. If you have any questions, please reach out to us at facts@wolfSSL.com. Thank you again, and we look forward to seeing you on June 18th for our webinar on how to get FIPS 140-3 for your Linux distro. Thank you all.